Hello everyone, welcome to ML with AP. The topic for today is outlier. This is the video 5 of the series of videos where we are discussing descriptive statistics. Let's learn. Now just as a quick recap, in descriptive statistics we primarily deal with two concepts, central tendency and dispersion. Central tendency deals with the location of the data. Dispersion deals with the variability or the dispersion or the spread of the data. The metrics for central tendency are mean, median, and mode. For dispersion, it's variance, standard deviation, range, quartiles, skewness, kurtosis. The topic for today is outliers. Let's see what outliers are. What are outliers? An outlier is an observation which is abnormal. In one word, if we have to define outliers, and as we understand in the common English language also, is abnormality, right? Something which doesn't fit the rule, right? That is abnormal and that is outlier. So in statistics, we define technically it as an outlier is an observation that lies the abnormal distance from the other values of the random sample from a population. So forget about that. Just understand that if you have a data series and there is one point or multiple points in the data series which are not located as the other points and which are very spread out, so spread out that probably it has not come from the same population, then that thing can be called as an outlier. Why does outlier happens? Sometime, if due to bad sensors, outliers can happen. Outlier is an anomaly which can happen because of various reasons, right? If in an IoT device, it can be a bad sensor. In a common, if you have to take example from our everyday life, then let's say the housing prices, there will be someone in a community. If you are predicting the housing prices for a particular city, there will be one person who will be a very super rich, ultra rich, and that can be considered an outlier. In case of a class, then there will be one who is super gifted child who always scores way above the others, then that person can be called as an outlier, or the performance of that student can be called as an outlier. So there are no fixed rules or no fixed definitions, but over and in general that it has to be very far away from the sample from which the population, so that we can safely assume that okay, it has not come from the same population. Okay, how to detect outlier? Again, there are no set rules for detecting outliers. It depends on the context also. Like, are outliers bad? Well, it depends. In some time, most of the time outliers are bad, and we have to deal it with somehow or with some mechanism in machine learning models, because the models doesn't behave very well with the outliers in place. But in some cases we are actively trying to assess and detect outliers. In those cases outliers become important, right? So it actually depends whether those particular machine learning models are sensitive to outliers or not, and based on that the treatment also happens. But apart from machine learning, if you have to see outliers, in some cases we go actively after outlier, and that the whole goal of the exercise is to detect those outliers. And in some cases we just ignore it, in some cases we remove it. So the treatment differs. But one of the mechanism there are various mechanisms to detect outliers also, that you have the statistical measures like Z statistics and various other mechanisms. One of the mechanism which is very popular is through the IQR and box plot, which we are going to discuss. So this is a quick recap. I have discussed this in the previous videos also, that what are quartiles and box plots, but we'll quickly go over one more time. What are quartiles? Quartiles is like if you have a ordered data series, ordered in ascending format, and if you're bucketing those data series into 4 buckets, the first 25% of the data, the next 25% of the data will hit the first 25% of the data. That means we are hitting the first quartile over here. That 25% of the data lies on the left side and 75% lie on the right side. Similarly, for median, that's a halfway mark, 50th percentile. Half of the data lies on the left, half of the data lies on the right. Similarly, for third quartile, 25% of the data lies on the right side and 75% lies on the left side. That's the third quartile. So that's essentially the quartiles are. How do we calculate that? Very simple. First, we calculate the median, which is the midpoint. This is our running example of the placement package of lakhs per annum for 15 students. I have done this in the sorted way over here. There are 15 data points, so my 8th data point will be my median because 7 data points are above that and 7 data points are below that. This is the 50th percentile or the median mark. Again, for the top 7, I have to find the midway mark to find my 25 percentile or the first quartile. Over here, if you see, there are 3 data points above that and 3 below that. So this 4th data point becomes my first quartile. Similarly, for 75% mark or third quartile, my data number 12 becomes my third quartile. So this is how we get our first quartile, median, and third quartile. Now, the box and whisker plots. So what are box and whisker plots or the IQR? IQR is nothing but interquartile range, which is Q3 minus Q1. So third quartile minus first quartile is my IQR range. Let's pay attention to the box first. So in this rectangle or a square, the middle line is the median, which is denoted by a thick red line. The left edge or the left boundary of the box represents your 25th percentile or the Q1, first quartile. The 75th percentile or Q3 is represented by the right side of the edge, okay? And these are called whiskers, the line which you see extended. Where they are extending to? They're extending to Q1 minus 1.5 IQR. What was IQR? IQR was my Q3 minus Q1. So from Q1 towards the left, you have to subtract 1.5 IQR, and the point where you reach, that will be your the left side end of your series and or the minimum. Similarly, Q3 plus 1.5 IQR towards the right will be your extremum for the right side or for the maximum value. Any value which is lying above Q3 plus 1.5 IQR should be treated as an outlier. Any value which is lying below Q1 minus 1.5 IQR should be treated as an outlier. Okay, so this is how through box and whisker plot and through IQR mechanism we try to identify outliers. Okay, clear? Now let's see it with our example. Now this is the data series which I was telling that placement package lakhs per annum in a sorted way. Okay, now how the box plot will look like. Now my population size was 15 because I have population or sample size was 15 because I have 15 data points over here. Clear? My median is 6. 6 is my midpoint. The 8th data point is 6. What is the minimum value? The minimum value is 3. What is the maximum value? Maximum value is 80. What will be the range? 80 minus 3, which is 77, will be the range. What will be the first quartile? The first quartile is 4 because my 4th data point is actually 4 over here. There are 3 above and 3 below before we hit the median. So that's the first quartile. The third quartile is 7. What will be the interquartile range? Interquartile range is third quartile minus first quartile. 7 minus 4, that is 3. What is outlier? Now, how to figure this out? Outlier. So I just, as I mentioned you just before that, Q3 plus 1.5 IQR. Anything beyond that should be treated as an outlier. So if you see over here, what is my interquartile range? 3. What will be the 1.5 of 3? 4.5. What is my third quartile? 7. So 7 plus 4.5, that is 11.5. If there is a data point in this series, which is anybody who has got more than 11.5 lakh per annum, should be treated as an outlier. Obviously 80 is an outlier. It is way above, right? Way abnormal. But anything which is above 11.5 lakh per annum should also be treated or considered as an outlier. That's why you see the outlier is being denoted as a single point, which is outside the whisker in the box and whisker plot, if you see over here. Now friends, one thing to note over here, let's see that what are the data points. So my median is over here. What was the median? My median is our 6. So the middle point over here, this is being represented as 6, right? What is my third quartile? My third quartile is 7. So right above 6, there is 7, which is third quartile. The first quartile is 4, which is being represented over here, right below 5, right? The lower edge of the rectangle. Now, how do you find the minimum and the maximum value? Okay. Now, outlier detection, I have already explained, that is like Q1 minus 1.5 IQR and Q3 plus 1.5 IQR will be outlier. But what are these points, the minimum and the maximum? So once you have defined the IQR, whatever is the point which is left in the data after that will be my maximum and will be, so when you discard the outliers, whatever is left in the data series after that and whatever is the minimum and maximum of that, that is represented as a whisker over here, right? So in this particular case, what we are discarding 80. Once we discard 80, what will be my what will be my highest point, or the maximum point will be 9. So 9 should be represented as my upper maximum whisker or the maximum data point. What will be my lowest? There was no lower abnormal outlier value over here, so my lower value will retain as 3. Okay, so this whisker is at 3, this whisker is at 9. Why it is 9? Because I have discarded 80 as an outlier, and that's why my the maximum value should be attached to 9, and that's how it is being represented. So this is how, through a box plot mechanism, we can quickly detect an outlier in a data set. Okay, now let's say we remove that. Let's say that particular outlier was not there. How would my box plot look like at that time? Okay, so I have removed. Now how many data points I will remain with? I have removed the 80 lakhs per annum lucky student. Now I have 14 sample size. My sample size or population size is 14 because I have removed the 15th data point. My median turned out to be 5.5, minimum is 3, maximum remains 9 because 80 is already gone, so maximum will be 9. My first quartile changed to 3.75, third quartile became 7, interquartile range 7 minus 3.75, 3.25. Outliers, there are no outliers over here. How did you figure out that the outliers are not there? Very simple. What you need to do is 7 plus 1.5 times 3.25. Now 1.5 times 3.25 will easily be more than 10, right? But we do not have any data point which is more than 10, so there are no outliers. On the lower side also, what we have to do, we need to see the first quartile 3.75 minus 3.25, which goes in the negative zone. There is no number. It doesn't even make sense to have a negative placement package, right? So there are no numbers. So there are no outliers over there as well. And when we plot our box plot after removing the outlier, it looks very neat and clean. Okay, so as you can see, the minimum value is 3, the maximum value will be 9 over here, no outliers. My third quartile is 7, my first quartile is 3.75, and the median is 5.5, right? So very clear, right? Friends, I hope you understood this concept of detecting the outlier through a box plot. Now the question to you would be that should we always remove outliers? The answer is, well, it depends. In some cases, outliers are the things which we are going after. Outliers is the thing which we are trying to figure out, right? In those cases, outliers are important. Lot of machine learning models does not work well with outliers. So there is a way, or there is a way to identify outliers. One of the way I've just taught you. There are other ways also, and we do the various treatments on outliers, right? So take, for example, credit card anomaly. Okay, so let's say a spending pattern of a particular Indian household. He was spending on credit card 4,000, 5,000 every week, or 10,000 every week. Suddenly the weekly expense went to 5 lakh rupees. Will that be normal? No, it should be considered an outlier because it is so far away from his normal expenditure habit, right? So credit card companies or the banking companies typically keep a tab on these anomalies, like, hey, this pattern of this particular customer was in this range, right? So it's like a box plot. It was in this range. If it is falling above your third quartile plus 1.5 IQR, should I treat that as an outlier? Should I intimate that whether his card has been stolen or somebody else is using his card? What is the reason? So it needs to be further investigated. That's why credit card company does. Average house prices in South Mumbai. Let's say you have you are doing analysis on the average house prices in the South Mumbai, and suddenly Mukesh Ambani house also appears on that lane. Now, should we consider that to predict the average house price in Mumbai? No, because that is way, way, way costlier than any other house in that neighborhood, right? So in that case, you should discard that. Average score of class. So in some cases in class there are few bright students who have scored way above the others. Should you keep that score? Should you remove that? Well, it depends on the context or what the teacher wants to do. So you can keep those outlier values also, or we can discard it also, right? So in discarding or retaining the outlier values depends on the context and the use case or the problem which you are trying to solve. Okay. So friends, with this being said, I would like to wrap this up, and in the next video I'll see you all over there.